Hi, I'm going to talk to you about coordinate geometry in the XY plane. I do love this topic because, as René Descartes thankfully provided for us, it shows us the link between algebra and geometry, equations and graphs. Okay, I find this subject really interesting and extremely helpful in being able to understand a lot of the more complicated mathematics. Okay, hope you like my background. Don't worry about copyright, there's none of that because obviously you can't see anything behind René Descartes, and here it's fine because I don't actually have the gun, so the gun logo is in no copyright infringement. Just writing down letters O and O and then a random 7 there doesn't actually give me any copyright issues whatsoever. Okay, but obviously it was nice to have this as a background, okay, because I do love Mr. Bond's films. Okay. Oh yes, René Descartes, and yeah, you could say coordinate geometry really started with him. All right. I'm just going to talk to you about what you need to know for this small section. It's mainly about circles. Again, another nice link there. Okay, using the circles. So it's mainly about circles that I'm going to be talking to you about in this section. Okay, so I'm going to start off with some basics. First of all, midpoint. To find the midpoint between two given points, you add the two x coordinates together, divide by 2. Add the y coordinates together, divided by 2. Essentially the same as find the median between two numbers. Okay? As a reminder here about the general equation of a straight line we prefer to use, y minus y1 equals mx minus x1. M being the gradient, of course, and x1, y1 being the coordinate point which the straight line passes through. Okay? Next up is a reminder about perpendicular bisectors. Remember those? Yeah. So if we talk about the line segment AB, a line segment is a finite length line. Okay, labelled at either end AB. If we talk about the line segment AB, the perpendicular bisector of AB is going to be a line that passes through the midpoint, the centre of the line AB, at right angles, hence perpendicular bisector. So you can see why midpoints are pretty important. Now this unit is about circles, so let me just show you how that links in. I'm going to remind you about a circle theorem you used probably in GCSE. The circle theorem is this: given that you've got a circle where O marks the origin, the centre of the circle, and given that you've got a chord on the circle as well, remember a chord is a straight line, passed through one part of the circumference to the other, not through the centre, otherwise that's called a diameter. Okay? The circle theorem is that the perpendicular bisector of that chord passes through the centre of the circle. And these things are all going to be related in quite an important way. The centre of the circle, pretty important in terms of getting the equation of the circle. Okay, and when you've got a chord, find the midpoint of that chord, also important, and we're going to be looking at equations of perpendicular bisectors as well. Okay, so that's some pretty handy information you need to know before you get started on the unit. I've just shut the blinds for this. You don't have to see me, it's not important. What you see on the screen is really important, okay, because I do love this moving image here, this GIF, okay, it's fantastic because I've got a fascination about orbital paths and about astronomy in general and space exploration, NASA. I'm really into all of that, okay. Anyway, the circle is what I want to talk about now, so apologise for this, I'm going to turn it off now, it's a bit mesmerising, I know, but the important thing is, in terms of the equation of a circle, that is the most basic equation, x squared plus y squared equals r squared, possibly met it at GCSE. It's for the simple case when the origin is the centre of the circle and the radius is given by r. However, in our case, we won't be dealing with just the origin being the centre, it's more likely to be somewhere else. And you've got the more general equation here, x minus a squared plus y minus b squared equals r squared. For the same radius, r, but the coordinates of the centre are a, b. Just think about your transformations of graphs for the moment. Just think about f of x minus a. F of x minus a is a horizontal translation to your right, isn't it? Okay. Hence the x minus a horizontal translation of the centre towards the right, a units. Similar with the vertical translation, y minus b, the transformation is it's moved upwards. Okay, so that's a pretty important equation that you need to be able to use and know for this unit. Okay. All right, I'm just going to take you through a couple of examples then involving circles. So the first example is this. The line segment AB is a diameter of a circle. Coordinates of A and B are given. So A is 4, 7, B is negative 8, 3. Find the equation of the circle. Okay. So the first thing to do is find the midpoint, isn't it? The midpoint AB, because if AB is a diameter, then the central point, the midpoint, is the centre of the circle. So I'm just going to write down here the centre is, and then let's work out the midpoint. So add these together, you get -4, divide by 2, so that's -2. And then add these together, you get 10, divide by 2, it's 5. So the centre is -2, 5. I'm just going to draw a quick sketch. You don't need to, but a sketch often helps you to see what's going on. So we worked out that point there, -2, 5. I'm just going to draw in a generic diameter here. So here it is. Don't worry if it doesn't match up to the actual problem. Okay. What we need to do is find the radius, okay, from the centre of the circle to the circumference of the circle. We need to find the radius. So choose any of these points. I'm going to choose that one there because it keeps things as positive as much as possible. And we need to work out that distance there. So remember how to do that? Using Pythagoras' theorem. Okay? So you've got that squared plus that squared equals r squared. So I'm going to write in here that r squared is equal to, and then find the horizontal difference between those and those. So that's going to be 6. So the horizontal distance is 6 between the x coordinates. So that's 6 squared plus, and then find the vertical difference, the vertical distance that is. So that's going to be 2. So 6 squared plus 2 squared. All right. So r squared is equal to 36 plus 4, which is 40. So you can write, if you want, the radius is √40. But we don't actually need to know what the radius is specifically, because when we put it into the equation of a circle, it's r squared is what we want, isn't it? So if you remember the equation of a circle, x minus a squared plus y minus b squared equals r squared. Can you see what I mean? We're just going to put that in straight away. And then here we've got the coordinates of the centre. So you've got x plus 2, because it's x subtract -2 squared, plus y subtract 5 squared is equal to r squared, which is 40. And there you go, that's our equation of a circle. Now in this example I'm going to show you what to do when the equation of a circle is given to you, but not necessarily in the form that you would like it. So for example this. That's an equation of a circle, but it's not written in the form that we would like it, is it? And by that, what I mean is this. It's not written in this form. X minus a squared plus y minus b squared equals r squared. This is our preferred form, because then reading those, we can see what the centre of the circle is, and reading that, we can see what the radius is. Here, it's not given that way, is it? Okay. So what we do is we complete the square. We complete the square on this given expression here. Before we do that, I'm just going to write the x terms together and then write the y terms together as well, and then the numbers on their own, like that. Okay. Then we'll complete the square on each bit. So complete the square on this bit first of all. That's going to give us x minus 7 squared subtract 49. This is not a lesson on completing a square. See one of my other videos for that if you didn't quite follow what just happened there. And then here, completing a square on these two, you've got y plus 8 squared subtract 64. And then you've got subtract 12 equals 0. We're almost there. We're almost there. So we've got the x minus 7 squared. We've got the y plus 8 squared. We just need to put the numbers together onto that side, don't we? So let's say we've got 64 and 49, so it's 113, and 12, 113, 115, 125. Okay, that is it. Okay, and that's a better form, because now we can write down that the centre of the circle, actually I'm going to specify this is a circle, and the centre of the circle is 7, -8, and I'll put down the radius of the circle is, well, I'm just going to leave it as √125. Okay, for the time being. Simplify that, so that's going to be 5 times √25. So 5√5. Okay. Hope you found that useful. So here's my next example. Circle C has equation x minus 2 squared plus y minus 6 squared equals 100. Show that. So to show that question, I'll highlight that. That means more working than is normal. Okay, should we say, is needed for this. Show that 4x minus 3y minus 40, that's an equation of a straight line, equals 0. Is a tangent to C. So let's just draw a quick sketch to see what's going on then. So here's a circle. not particularly well drawn, I have to say. What's the gradient of this line going to be? That's going to be 4 over 3. Yeah, so let's just draw it like this, okay? Right, so that's a tangent to the circle, okay? What's actually going on? Well, when you've got a straight line in a circle, one of three things happens, really. Either you've got an intersection between the straight line and the circle, it crosses it twice, there are two solutions to the equation we're going to solve, or, this case here, it just touches the circle at one point, so it's a tangent, one solution, or it completely misses it, there's no intersection whatsoever. Okay, so one of three things, intersect twice, tangent, or not at all. And of course, what I'm trying to get you to think about is the solution to a quadratic equation, whether you've got two real roots, one real root, or no real roots. And that describes perfectly what's going on here, okay? This is a nice question, I do think it's a nice question, in simultaneous equations with a quadratic and looking at what the discriminant is, okay? So as you know, when you've got the intersection between a line and a curve, you need to solve them simultaneously. So let's get on with that, shall we? So we'll need to rearrange this, make either x or y the subject. I'll tell you what, let's make y the subject, shall we? So that will be 3y is equal to 4x minus 40. And then, of course, to put it in there, we'll need to divide throughout by 3. So that will be y equals 4 over 3x minus 40 over 3. And then we'll put it in here. All right. So substitute in, we've got x minus 2 squared plus y minus 6. So it's 4/3 x, and then that subtract 6. So 6 is 18 over 3, so that subtract 18 over 3 should be negative 58 over 3. Okay, squared equals 100. And now we just need to expand the brackets here. So this is looking like it's a bit challenging in terms of the number work, but nothing we can't handle because we're doing A-level mathematics, don't forget. So what I'm going to do is I'm going to rewrite this, all right, if you don't mind. I'm going to rewrite it as 4x minus 58 all over 3 squared. It's just going to make expanding of brackets simpler. Okay, so if you don't mind, I'm just going to rewrite that. I've written it there so I don't make any mistakes when copying out again. So 4x minus 58 all over 3 squared. All right, and then we're ready to go. So let's do the expansion. So this one, this is the easy one, isn't it? X squared minus 4x plus 4. And then this one, numerator first. So 4x all squared, 16x squared. And then subtract 58 times 4, that's 232, doubled, 464x, and then plus 58 squared. Yeah, calculator time. Yeah, there are times when mental maths is great, it's got its place, but something like this, very quick and simple, isn't it? So 3,364. Let's not forget to divide all that by 3 squared, which is 9, and equals 100. All right. I might need this again, we'll see. And we need to solve that. So the first thing I'm going to do is multiply everything by 9. So if I multiply everything by 9, the right-hand side becomes 900. This I can just get rid of. And this becomes 9x squared. That becomes 36. And that becomes 36, negative 36, of course, x as well. Agree with that? Hope so. Well, we'll know if we're right or wrong because well, this question turns out because we need to show that it's a tangent, okay? And if I don't get it right, it won't be a tangent, it'll be something else. So let's add these together. So 25x squared, okay? And then this and this. Ooh, so it's going to be not so bad actually, 500. It's a nice round number, isn't it? All I'm after is another round number towards the end, and then fine. 36 plus that, nice. 3,400, and then subtract 900 from that, 2,500. Oh, isn't it? Isn't it nice when things just work out that way, okay? When you've got awkward things like this, the fractions here, and then all of this, because I'm just going to divide that by 25 now. That's absolutely lovely. I really am loving the way that's worked out. So divide by 25, we've got x squared minus That'll be 20x, and then this will be 100 is equal to 0. Lovely, I can see how that factorises, can you? So there's two ways of doing this now. Either you factorise that as x minus, actually no you can't, yeah you can. You factorise x minus 10 squared equals 100, and then you write x equals 10 only. And then you say, therefore, this is a tangent because there's only one solution. Okay? Or alternatively, you look at b squared minus 4ac, because remember the discriminant determines how many solutions we've got to a quadratic. If there's just one solution to this quadratic here, that can only mean one thing, that it's a tangent. The line is a tangent to the circle. So we look at the discriminant is 0, so we better put that in. So b squared, that's 400, subtract 4ac, 4 times 100 equals 0. And then you've got, therefore, one solution. Notice that I've tied that in, because therefore one solution works with this, and then the x equals 10 only, therefore one solution works with this, and therefore the line is a tangent. Let's just finish it off. Is a tangent to C. Okay. I'm hoping you enjoyed that. Rather than me to do a couple more examples, let me just talk to you about a couple of alternatives. You could get a circle that's got this equation, find the intersection points between the line and a circle, in which case you do exactly the same thing, except by the time you get down to the quadratic equation stage, if there are two intersection points, you'd have two possible answers. Okay. It could be a question where you've got to show that a line does not intersect or touch a circle, show that this does not intersect or cross a circle, in which case, again, you do the same thing, but this time you look at the discriminant is negative, and when the discriminant is negative, you write down there's no solutions, therefore it does not cross. Okay. So it's a lovely question with lots of different possibilities. Hope you enjoyed it as much as me. Right, so for my next example, I'm going to go back to the previous question and just reword it slightly, okay? So if you remember my previous question, we had this as our equation of a circle, and then to show that this here was a tangent. So I'll just rephrase this one and put it the other way around, okay? I'm going to ask you to find an equation of the tangent to the circle at a particular point. Okay, remember x equals 10 was the solution to the quadratic we ended up with. So what's different about this is that we know that we're dealing with a circle and a tangent, but we've got to find what the equation is. And all we've got is that the tangent occurs at the point 10, 0, and we've got the equation of the circle. That's it, got to find the equation of tangent. So as you can see, the mathematics involved here is going to be different. It's going to be a different strategy to what we did before. Before we need to use simultaneous equations, but we don't do that this time because we don't have the two equations. So what do? Well, let's just help ourselves by writing down something from the equation of the circle. We know that the centre of the circle is at 2, 6. So let's just write down that, shall we? So 2, 6 is the centre of the circle. Okay, and we need to find the equation of that line. Well, don't forget the equation of a straight line is of this form. Y minus y1 equals mx minus x1. And what we need for the equation of a straight line are two things. We need the coordinate of the point it passes through. That's easy. 10, 0. So going well so far. And we need the gradient, which we don't have. So we've got to work out what the gradient is. And that is our strategy for the question, find the gradient. So how do we do that? Well, we need to use the fact that the tangent is always going to be perpendicular at right angles to the radius at the point of contact. Remember that circle theorem? Tangent circle is always at right angles, perpendicular to the radius at the point of contact. And what we can do is we can work out the gradient of this point here. Okay, we can work out the gradients from here to here. So I'm just going to call that point O for origin, okay, if you don't mind. I'm going to call that point A, and here I'm going to write down gradient of OA. So it's the gradient of this radius line here I've drawn, okay? So let's look at the difference in y coordinates. So 6 subtract 0 is 6, and difference in x coordinates, 2 subtract 10 is negative 8. And I'd expect a negative gradient anyway, just from the way I've drawn my line, to be honest, okay? and that simplifies, of course, to negative 3 over 4. So the m that I'm going to use there, okay, must be 4/3. Can you see that? Because we're using a rule that the product of two gradients that are perpendicular, two lines that are perpendicular to each other, the product is -1. Or just take the negative reciprocal of that, 4/3. And then we're ready to go. So our equation must be y subtract, I'll put in 0, so you can see the substitution. M is 4/3, and then you've got x subtract 10, okay? And it's just tied it up a little bit, so you can either leave it as y equals 4/3 x subtract, that's going to be 40 over 3, or why don't I just tie it up with the previous example we went over and just multiply both sides by 3 to get 3y equals 4x minus 40, and then write it in this form, 4x minus 3y minus 40 equals 0. If you go back and replay the video, I'm sure you'll find that was the equation that we had in the previous question. Okay, so a completely different strategy, notice, for a slightly reworded version of that question. I'm hoping you found it useful. I'm hoping you found all of these examples useful, by the way. Okay, the next best thing, of course, is to practice. Just try and do as many questions as you possibly can. I'm hoping that goes really well for you. Okay, but if you don't, if you're stuck, obviously, just come back and watch these videos again. That's why I do these things. You can't ask your teacher to replay your lesson. Once it's done, it's done. But with the videos, that's why I'm doing it. You can just replay it as much as you like, okay? I really hope you find them useful. Have a good day.